Hello everybody, welcome to chapter 1 worksheet 1. So in this chapter we'll learn about sets, right? We'll learn how to given, let's say, a certain bunch of numbers, right? How are we able to then be able to look at the characteristics of these numbers and then after that group them into a certain into a way of describing them into a certain group, right? Into just how, if I look at some numbers, how is it that I'm able to look at these numbers and be like, hey, this is what it represents? Okay, so in today's worksheet, in worksheet 1, okay, I'll be bringing you through what does the word set mean, what does the word elements in a set mean, right? Then we'll also be talking about equal sets, empty sets, right? So all these things that we'll be talking about today. Okay, so just one thing to note, if you were to see this robot, okay, in any of the worksheets, okay, please note that this robot, there'll be some pointers there for Desmos activity builder. Okay, then after that you can check in with your subject teacher, your math teacher, on what is the code for this Desmos activity builder. Okay, so let's start. Now, some things before we start learning about sets, I think it's again because you see, when I want to describe a certain set of numbers, I will need to know some different math terms on how to address them. So let's go through the first one, factors. So what I was saying earlier is, let's say I give you these numbers 1, 2, 3, 6, 9, 18, right? Then after, it might look like some random number to someone who don't learn maths, right? But to us, we look at this, more or less we should know that these are factors of 18, right? I mean, of course, on one hand, you cannot tell immediately lah, but for some of you, but it's okay, through practice you'll get better. Okay, so factors of 18. So if I were to call this into a set, okay, so note that with sets we use curly brackets to denote sets, right? We can say that, hey, this set A represents the numbers that are all factors of 18, something along these lines. Okay, I'll bring you through more, okay, once we are more familiar with this. Now, next one, multiples. Okay, 0, 3, 6, 9, 12, blah blah blah. Again, as mathematicians, at the tip of our fingers we know that, hey, these are multiples of 3. Prime numbers is something that I feel like a lot of us, okay, at one glance we may not be able to see that, hey, these are prime numbers, but through a lot of practice, and I think most of the time people do use prime numbers because it's a bit harder than, let's say, multiples or something. So prime numbers, again, 2, 3, 5, 7, 11, again, something you need to know at the tip of your fingers. Now we move on to composite numbers. Okay, so what are composite numbers? Just again to recap everybody's mind, composite numbers are numbers that has more than two different factors. So for example, we look at an example on 4, right? 4 is 2 times 2, 4 times 1. So here I can see 1, 2, 3 factors already of 4. So since there's more than 2, then we can say that 4 is a composite number. Okay, now even number, odd number, all this I think we all understand. Perfect squares, okay, perfect square is your 0 square, 1 square, 2 square, 3 square, 4 square. So all your integer square, these are called perfect squares. Okay, now the perfect cube is what? Again, the same idea lah. 1 cube, 2 cube, 3 cube, 4 cube, so on and so forth. Right, so this will give you a 0, your 1, your 2 cube gives you 8, 3 cube gives you 27. Now, maybe something that we can add here also is the number 0. I just want to bring to your attention here, the number 0. Okay, maybe you can just write it down in your book, in your notes. The number 0 is actually not a positive nor a negative number, because this number 0 holds nothing, right? So in your question, sometimes you will see the word non-negative. Sometimes you will also see the word non-positive. And if, let's say, they were to ask you for non-negative integers or non-positive integers, please do make sure to include 0 inside. Okay, I mean, as long as it fits the range lah, right? Less than 5. If, let's say, ask you for non-negative numbers less than 5, then you know 0 must be inside. Okay, because I feel like last year when I was teaching the Sec 4 batch, they totally forgotten about this. So I put it here just to recap everybody. Now, then we talk about inequalities. I think at this point we all know, okay, with the line below means include an equal then. Huh? No line below means just smaller than. There is no equal than there. Okay, then if it's pointing the other way around, the inequality, the larger side, this side here is pointing this side as compared to this side here, which is the smaller side, right? We say that 8 is bigger than or greater than 3. Okay, now then let's go on to talk about sets on itself. Okay, now in everyday life, we often encounter a collection of objects such as pile of books, fruits, students, dolphins, right? We use things like pile, basket, class, and school to describe the different collection of objects. Okay, so in mathematics, we use the term set to describe any collection of well-defined and distinct objects. And the objects in a set are called elements. Okay, now please take note this one. A set is denoted by a capital letter. Again, this is through convention, because when we describe the elements in a set, we will use small letters, so we do not want to confuse anything. I mean, capital letters can also be used, but by default, we do most of the time we use small letters. Okay, now let's talk about describing a set. Okay, describing a set in words. Okay, for example, if I were to say, let set M be the set of months in a year, then at the back of my mind, we know January, February, March, April, May, blah, 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 right? So if let's say I ask you to list means to name all the elements, right? If I ask you to list, then you must tell me, okay, set M equals to, now we use curly brackets here, and you can see that every single element here is separated by comma. Okay, so we use curly brackets. Again, I repeat, we use curly brackets here. That's rule number 1, to use curly brackets to denote a set. And then next one, we use commas to separate elements. Okay, now, so this is, we have already learned 2 things. We have already learned how to describe a set in words, right? We say M is a set of months in a year. We also learn how to list the elements in a set. Okay, now number 3. Okay, now we also need to learn how to describe elements in a set in set notation. Now, what does set notation mean? Okay, set notation just basically means whatever I mentioned here, right? To actually use curly brackets to denote a set. Okay, so for example, if I were to say M is the set of months in a year, now, then again, to denote in set notation, what we must do is we must again have M equals to, okay, then now set notation means we got curly brackets, curly brackets. Now, what else must we look out for? M is to M. Now, what does this mean? This means that every element of M comes from this entire statement here. So, now this small m here, this one, okay, actually tells us that, hey, what is M? What is the small element M? Then you look at the descriptor. The descriptor is the one I underlined in red, and M is the month in the year. Then you're like, oh, okay, so if I were to list out M, I will know that I can list out everything as seen in part 2. Okay, so it's important. So let me tell you what's the usual that you have. You have equals to curly bracket. You have the element, the dot is important as well. Okay, and of course the close bracket. Okay, we will look at some more examples, don't worry, okay, to see how we can further go on to describe things in set notation. Now, let's move on. For example, okay, let S be all the vowels of the English alphabet. Now, I think this point I must also be a bit of your English teacher and tell you, vowels is your A, E, I, O, U. The opposite of vowels are what? Are called consonants, right? Like your non-vowels lah. Your B, your C, your D, your F, your blah 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 blah. Okay, so let S be the set. So this is called listing out all the elements, right? We list out all the elements in set S. Okay, so A, E, I, O, U are elements of set S. Now we're going to learn some more new symbols. This symbol here is a very important symbol because it cuts down your writing by a lot. Okay, so for example, this symbol here, okay, is used to describe is an element of. So if I were to look at element A here, I want to say A is an element of set S. I just need to write this. Now B is not a vowel, but it's a consonant like I mentioned earlier. So how to say B is not an element of set S will be just an element slash. That's it. Okay, now look at S. How many elements, how many members are there in S? A, E, I, O, U. 1, 2, 3, 4, 5. There are 5 members altogether. So now we want to denote how many members there are altogether. We will put N, which stands for number of elements in set S. There is 5. So you see, all the symbols are very useful, right? Because it cuts down your writing by a lot. Really, really by a lot. Okay? Let's move on. Now, this one here, I think you can go through with your friends in class. Okay, I believe your teacher already went through with them, so you can use their OneDrive, okay, to look at your teacher's solutions. Okay, let us continue. Actually, you know what? Let me go through this with you. Sorry. Let me go through this with you. Now, let's look at set A, okay? You have no one to discuss at home with, so let me sit down and discuss with you now. Write as many descriptions as you can think of. Describe the above set of numbers in words. Okay, now. So, again, since they want me to describe, not to list, to describe. So, again, A equals to curly bracket X dot dot X, right? We need to put our X there to tell them that, hey, this is what X is. Okay, so first of all, we can see that set A, 2, 3, 4, 5, 12, 13, 14, blah, 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 are all integers. So we say that X is an integer. Okay, now, between 2, 3, 4, 5, 12, 13, do you see any relations? How a bit hard to see, right? I don't really see a relation myself also, because they're all consecutive numbers, so it's not even, it's not odd. They are not prime numbers as well. I don't think they are factors of anything as well, right? Because there's a 17 there, it just throws everything off. So if there is nothing what to do, okay, simply just tell me the range. X is an integer from what? From X from 2 to 5, or 12 to 18. Okay, so this would be a perfect answer, right, for you to describe set A. Right, you really covered everything, right? You tell me that X is an integer, okay. X is in between 2 and 5 inclusive, okay, I see that. Between 12 and 18 inclusive, also I see that, so it's more than okay. Now we go on to set B. Okay, we go on to set B. Now for set B, again, 3, 5, 7, 11. There at the back of your mind, you might be thinking, hey, these are odd numbers, right? But then at the same time, you see, no 9 war, no 15 war, so cannot be odd number. Then again, you think, can it be prime numbers? They must be thinking, but 2 is not there. But then 3 is there, 5 is there, 7 is there, 11. Everything else is prime except for 2. So how? You can also write this now. X is a prime number, right? Then you can tell me that X is in between 3 and 23 inclusive. Okay, so you see, it's very straightforward there. Okay, really, you just want to cover your bases and make sure you are as explicit as possible, but also being as detailed and specific and sweet and short and sweet at the same time. Okay, so now you want to put it in the most concise way possible. Now, concise just means that I want to at one glance see everything. It's the most to the point, right? So set A will be just list everything out lah. Okay, Mr. Tan has already given you the curly brackets already. So just list everything out. And you're good to go. Okay. Now, with question 2, you swap with me. I also cannot see your work. Okay, so let's go directly to question 3. Okay, which description in set notation do you like the best? Okay, I mean, it's your own personal preference lah, but honestly, you ask me, Mr. Tan will prefer number 2. Why? It's because at one glance, I can really see what is inside. I don't need to be like, oh, guess. I don't need, okay, X is a prime number. Work out the prime numbers in my head, one by one by one. No, I really see the most easiest way already. So personally, okay, it's your own personal preference lah. So you want to write your own, you can write your own reflection. I like the concise way the best. Why? I can see all the elements in one glance. Hopefully you can read my handwriting. I can see all the elements in one glance. Okay, number 4. Would this way of describing still be your favorite if the set becomes a lot larger? Of course not lah. How? Imagine Mr. Tan asks from 1 to 1 million. I cannot write everything, right? So, of course, no. It will not be. Right? So, let's give an example. For example, let A be the set of numbers. Sorry, not the set of integers, even integers from 0 to 1000. It would be time consuming and impractical to write down all the elements. Actually, in that case, then I think describing the set will be much easier. Alright, so let's say if number 3 you say, oh, I like to write the set more. Sure, up to you, go ahead. But then in this case, you will be agreeing lah. Okay. I mean, if you need to pause, you can just pause. I'll just continue. Okay, so let's go on to talk about distinct objects in a set. Now, consider a pair of identical twins, Ethan and Michael. Ethan and Michael are identical, right? They look the same, maybe. But do they talk the same? Are they hungry at different times, same times? I don't know. I don't have kids. I don't know, right? But of course, I would think that Ethan and Michael are different people, right? I mean, they are identical twins, but I call Ethan, cannot Michael respond to me, ma? So, what do we call them? They're identical, but they are distinct. Right? They are distinct. So, they must have their own sense of identity. They must be able to react to different names. They're distinct. Okay? So, now let's consider the next question. Let T be a collection of 2 identical pens. Now, in that case, since I got 2 pens, how many elements do I have in T? I have 2 elements lah. If I'm using red, I have 2 elements. Now, which one do you think we should list the elements of T? Now, first thing, if I look at the elements like that, are they distinct? Am I able to tell the first pen and the second pen apart? No, ma, right? They look like the same P to me. Okay? Hence, we do not write T equals to, oh, this is very small, sorry. Hence, we do not write T equals to PP because the elements P and P are not distinct. Now, as there are 2 distinct elements in the set T, okay, we know that they are distinct. I must be able to tell the first pen and the second pen apart, right? We write this P1, P2. Now, notice that they use the same P, but because I want to be able to tell these two distinct pens apart, one is P1, one is P2. Okay, this part I hope you all understand. If you don't understand, please look for your subject teacher. And if you belong to my class, look for me. Okay, now we look at question 2. Let S be the set of letters in the word clever. How should we write the list of elements of S? Now, is the letter E distinct? That means if let's say I were to write them all each on cards. Right? If I have to write them all each on cards. And then after that I jumble them up all together. And then this E and this E here, I were to mix them up like that. Do I still spell the word clever? I do. Right? I still spell the word clever. Does it matter which E goes where? It doesn't matter, because it's not like the pens where this pen maybe got less ink, this pen maybe got more ink, but they're identical. Right? They are distinct. But in this case, the E is not distinct. Right? The cards are exactly the same. They look exactly the same. And it doesn't matter where I put them. So the letter E is distinct? No lah. It's not distinct. Hence we write S equals to, no, since they are not distinct, we can put C, L, E, V, R. Right? Because in a set, I shouldn't repeat the elements twice. Now, then you must be thinking, hey, Mr. Tan, in that case, how do I tell people that there are two E's in the word clever? If they're clever enough, they'll know lah. But also at the same time, so you see, when you describe the set notation that time in words, they say let S be the elements in the word clever, like what we've written here. Then I know that, hey, this is what it means, right? But if you decide to put in set notation, you cannot repeat the E. Cannot, because you cannot repeat the same elements twice. Okay. Also by default, okay, usually we arrange our elements in ascending in alphabetical order, but again, you do not need to do that lah. Okay, if you waste your time. Clever like that with CLEVR is also fine. Okay. Now let's go on to example 1. Let's start the first example. Given the set A is a positive odd integer less than 10. So once I get this right, what a habit I like to do is I like to list all my elements out. So positive, can I add 0? Cannot. Odd integer less than 10. Odd. 1, 3, 5, 7, 9. Okay, so I know that this is my starting elements that I should start with. List the elements of the set A in set notation. So they asked me to list the elements. 1, 3, 5, 7, 9. Find the number of elements in A. Number of elements in A. Again, we use n bracket. How many elements are there? 5 elements lah. Okay, is 2 an element of A? Is 2 in this set here? Obviously not lah. I already asked for odd already. So we say 2 is not an element of A. Now let's move on. Given the set V is all the letters of the word mathematics. Now again, we know, right? We know that A and A, like we said earlier, they are not distinct. Okay, so again, as a habit, let's write down the letters that are distinct first. So I see an M, I see an A, I see a T, H, E. M is repeated, A is repeated, T is repeated, I, C, S. So we know that V is M, oh dear, M, A, T, H, E, I, C, S. Find the number of elements in V. 1, 2, 3, 4, 5, 6, 7, 8. Like that lah. I think should be quite straightforward lah. Okay, so again, as I was mentioning earlier, this code, please check in with your teacher, subject teacher, on what this code is. Okay, let's go on to the next one. A finite set and an infinite set. Okay, Now, finite obviously means countable. So it's where I can put all the elements in one set. Okay, finite here means countable. Okay, infinite that means I cannot finish writing one. I will just keep on writing. Even after you leave YTSS, you will still be writing, right? So, can you give an example for finite set and an example for infinite set? Okay, so let's let our finite set, let's call a finite set F, right? So let's call F, let's give an example. What is finite? Okay, like just now we saw X is the positive odd integer and X is less than 10. Right, so this is an example of a finite set. Okay, now then what about infinite set leh? Okay, I think we rarely say the word infinite. We say mostly infinite. Okay, now then infinite set we use y to denote. Then we could be like y is maybe the whole set of prime numbers. Right, the whole set of prime numbers. Right, we can never finish writing. Right, do you know that until this day they're still discovering more and more prime numbers? Right. Wait, what's the name for it? Let me find it for you. Okay. Okay, never mind. I think it's a bit too high level. Okay, let's move on to the next one then. Empty or null set. Okay, so we usually empty set means what? Empty means nothing in the set lah. Oh, nothing in the set. So if there's nothing in the set, we denote usually by this. I would like you to choose this element instead, this symbol instead, called phi or phi. Okay, so this is the empty set, which tells us that straight away I see nothing, no sets in the no elements in that set. Okay, so for example, what is an example for empty set? Okay, let's call it E. Let me call Z. So Z is the set of prime numbers less than 2. Right? You don't have prime number, I start with 2 So you tell me less than 2, not less than or equals to, but less than 2. I know that don't have. No prime numbers like that. Okay. So attention. So one thing to note here. Now it's a bit confusing. This one versus this one. Now, if I say that A equals to this, okay, the first one will tell me that, okay, there's nothing in the set. Okay, but if I were to say B equals to this, number 2, okay, then I can say A. But in that set, there is an empty set element. So B is not an empty set. You see the difference? A is an empty set. B is a set consisting of an empty set. Okay, are people that crazy? Yes, they are that crazy. Okay, but it goes to show that B has that one element. So that's why B is not an empty set. I hope you see the difference here. Okay, let's go on to talk about equal sets now. Okay, two sets are equal if they contain exactly the same elements. Now, it does not matter the order. Okay, as long as they contain the same exact elements, okay, we know that for a fact that they are equal. So therefore, if A equals to B, then we say that NA, the number of elements in both are the same. It must be one, right? It must be. So let me write it down here. Let me write it down here as a summary. If A equals to B, the sets are the same, then we know that we have this relationship. Okay, now some of you must be thinking already, Mr. Tan, is the converse true? Okay, that's what we're going to explore. Now, if A and B are two sets such that A equals to B, is N equals to NB? Yes. Okay, I already mentioned to you. Yes, they are. They contain the same exact number. Actually, same and exact the same word. Never mind lah. Mr. Tan like to exaggerate. Same exact number of elements. Okay, now then number 2 will teach us about the converse. If A and B are two sets such that NA equals to NB, is A equals to B? Is it always true? Now maybe you can pause the video here and think of an example where it is not true. Okay, you thought of an example already? You thought of your answer? Is your answer the same as mine? Okay, let's see. Mr. Tan like that ask, confirm the answer is no, right? So the answer is no lah. Okay, why? So for example, if A equals to 1, 2, 3, 4, okay, and we call B, we call equals to 5, 6, 7, 8. Simple example, right? I know my NA equals to 4, which is the same as my NB, but A is not B. Can you see that? Right, both have 4 elements in each of the set, but they do not have the same elements. So of course not lah. Okay, so this one obviously we know that this is not true. Okay, we know that the converse is not true. Now, are all empty sets equal? What do you think? Of course they are lah. They do not contain any elements. So of course if they don't contain elements, everything goes 0, 0, 0, 0. Nothing to talk about. Okay, now let's go on to the last one. Example 3, list the elements of the following sets in set notation. Just to ask you to list lah. Okay lah, can list lah. So x is a positive integer and 5x is less than or equals to negative 16. Wait, I'm sorry, 5x is less than or equals to negative 16. So x must be less than or equals to negative 16 over 5. Right? But if I were to use 16 over 5, I know it's negative 3.2. So x must be a number that is smaller than negative 3.2, so more negative. But they want positive integer, then how? P equals to empty set law. There's no elements, nothing. So exam time, they can trick you like that. So you don't need to die give me an element one, but also don't everything give me empty set lah. Check first. Okay. Now X is an integer where 5x is less than or equals to negative 16. So again, the same inequality, right? So Q must be inclusive of negative 4, negative 5, negative 6, negative 7. When do we stop? Okay. So we just put ... because we know that this is an infinite set. Now, is P equals to Q? Was Mr. Tan okay when he said this question? Of course, the answer is not. P is not Q. Why? P is an empty set with 0 elements, while Q is an infinite set with infinitely many elements. Okay, so that's it for this chapter. Today I hope I brought you through all the different kind of elements and everything and sets notation, and we have seen how to describe an empty set, how to describe an infinitely many set. We've also seen how to equal sets, right? Whether the converse is true. We have also seen how to whether distinct or identical, how to tell them apart, when to include the P1, P2, when to not include it, right? We have seen that all today. Okay, so for my class, okay, homework in I would like it to be in on the 9th of Jan. 9th of Jan. Okay, then for the rest of you, you can check in with your own subject. You know what? 10. You'll end on Tuesday, 10th of Jan. Okay. This is for 2025 batch. Okay, the other years one you check in with your other subject teachers. Okay. Thank you, everybody.